Okay, ladies and gentlemen, so what I'd like to do is show you how to find the distance between 2 points. And we're going to do that by using the distance formula. Now, but before I get into the distance formula, what I'd like to do is just kind of make sense when we're given a problem and we need to find the distance. I think the easiest thing to start doing is to first kind of graph and plot the points. And I'm going to kind of work with some basic ones so you can kind of see where this distance formula kind of involves. But if you remember, we previously did the distance between 2 points on a number line. And finding the distance between 2 points on a coordinate grid is going to be very similar to that and very much related. So the first thing is, if we're given 2 points, we want to find the distance. One thing we can do is just plot the points. So I have A is at -3, 2. And then whenever you plot a point, make sure you label it. And then I have another point at 1, 2. So when I want to find the distance, you can see that the distance between these 2 points is a horizontal distance. So it's almost like it's on a number line again, right? And if you remember, we're finding the distance between 2 points that are on a number line. We're just subtracting them and taking the absolute value, because distance is how far it is from one point to the other, not dealing with direction, if it's left, right, and so on and so forth. So all I need to do is just take the absolute value of b minus a in this case, and we're only going to be dealing with the with the x coordinates, because obviously the y coordinates are unchanged, right? So therefore, I'm just going to do 1 minus -3. And you can see that distance is equal to the absolute value of 4, which is equal to 4. And again, I'm choosing a very basic one because obviously, would you really want to do all that? Would you really do this work on this problem? No, you would actually just count 1, 2, 3, 4. But I want you to kind of see how the distance works. Same thing, even if you're going to do a minus b, this absolute value, that would be equal to -3 minus 1, which is equal to absolute value of -4, which is equal to 4. I just want to kind of go back for you to remember that distance, because once we get to more difficult problems, we're going to want to make sure we kind of understand why it works. In this next example, I have c and d. So I'll go ahead and plot these points. So I have -1 up 2. That's going to be my c. And then my d is at -1 down 6. 1, 2, 3, 4, 5, 6. Now in this one, I'm not going to go through the distance. I'm just going to count them. Because you can see in these points, I can easily just count. So -1 up 2, and then here I'm going down 6. So if I'm going down 6 and then up 2, that means I have a total distance of 8. Okay, and here my distance is equal to 4. All right, so that's kind of how we're going to when we have vertical and horizontal, and that's very much related to what we learned previously by using a number line. But when we get to the next example, we have a point E, which is at the origin. And then my other point is at 1 up 4. 1, 2, 3, 4. That's not where it was supposed to be 3, 4. Sorry, 1, 2, 3, up 4. So the problem in this example is we know how far it is horizontally, and we know how far it is vertically. But we don't know this direct distance. Now, fortunately, though, for us, what we can do is if we kind of notice this horizontal and this vertical direction, we could say that this units 4, this units 3, and then therefore, by the Pythagorean theorem, we can understand that this is a Pythagorean triple, and my distance is going to equal 5. If you're not following me with that, if you remember Pythagorean theorem, a squared plus b squared equals c squared. Leg squared plus leg squared equals the hypotenuse squared. So you had 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared, root. C equals plus or minus 5. But since we're talking about distance, we're only going to be dealing with the positive value. So therefore, c is equal to 5, which is my distance. So the important thing I want you to understand is if we're given 2 points, basically what we want to do is find the horizontal and the vertical distance, and then basically use the Pythagorean theorem to go ahead and solve for that. And that's exactly where the distance formula is derived. So if you think of Pythagorean theorem, a squared plus b squared equals c squared, let's call c squared the distance. So we'll say d squared is equal to the length and this width. Now, again, how do we find those distances? If it's not something that we can easily count, how do we do that? Well, we can go back to this. We can find the difference, right? But the important thing is, since we're squaring each one of these distances, we don't need to use the absolute value, because anytime you square something, that's always going to make it positive. So we're basically going to be doing what we're going to call this is, like, if this is x1, y1, and this would be x2, y2, to find the distance horizontally, what you're doing is y2 minus y1 squared plus the difference in the horizontally, which would be x2 minus x1 squared. And therefore, then really to solve for d, you're going to take the square root. So you have d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. I don't know why I wrote the y's and the x's differently. It really doesn't matter. You're adding them. But anyways, that's going to be the formula that we're going to use. And I'll show you guys how that works here. So let's go and plot this next one. So I'm at 1, 2, 1, 2. So that's g. And then my next point is at 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's at h. So again, we're trying to find this distance, right? And the only thing we know here is, what is this change here? Now, fortunately for us, we can count this, right? So we know this is 1, 2, 3, 4, 5. And this change is 1, 2, 3. So you could just use Pythagorean theorem from here to go ahead and find this. But let's go ahead and plug this into the formula so we can kind of see what this looks like. D equals, and again, remember, we should get 5 squared and 3 squared under the radical. So we're going to do x1, y1, x2, y2. And I always just kind of go in order, always labeling them like in that order, because it really doesn't matter which one you label them, because again, remember, you're squaring them. Just like the absolute value always going to make them positive, when it doesn't really matter the order, because since you square them, you're always getting that distance, which is always going to be positive. So let's do x2 minus 1. Uh-oh. 1, 2, 3, 4. That's 4. I counted that wrong. 5 minus 1 squared plus 4 minus 2 squared. Did I count these wrong? 2. Oh, 5, 4. 1, 2, 3, 4. I graphed that wrong. 5, 4. So that should be 2. Well, good. We can see I'm catching my mistakes, right? So therefore, d equals the square root of 4 squared plus 2 squared. And that's exactly what we would have done anyways. If we were going to use the Pythagorean theorem, we would have squared these two to find c. Well, now we're really calling c d because d represents distance. So anyways, we have 4 squared is 16. 2 squared is 4. So therefore, the square root of 20. And then one thing that we'll be practicing often in this class is simplifying our radicals. So therefore, I can break this up into the square root of 4 times 5. And the square root of 4 is going to be 2, radical 5. OK? So let's go to the other one. Rather than graphing them, I'm just going to get right into the distance formula. So I'm just going to label this x1, y1, x2, y2. Because even though the distance formula is or as far as graphing them is very helpful to visualize, obviously I can do a lot of this math very kind of quickly in my head now that I kind of have an understanding of how things work on the graph. So just got to be careful that you're plugging in the correct numbers. And also doing parentheses. This is 2 minus a negative 3. So notice how I'm using my parentheses. And then I have 3 minus 5 squared. OK? Now again, notice here that even though I'm subtracting 3 minus 5, I'm going to get a negative. But the squaring is going to make that positive, because remember, distance is always going to be positive. So 2 minus a negative 3, that's going to be a double negative. That's going to equal adding, so that'd be 5. So 5 squared plus negative 2 squared equals 25. I'll just write it one more. 25 plus 4 equals the square root of 29. And we cannot simplify the square root of 29 any further. Like this problem we could, but square root of 29 we cannot do any further. And then last but not least, let's just do one more, and I'll kind of do this one a little bit quicker. I'm not even going to label them. I'll just say x1, y1, x2, y2. So therefore, I'll do 5 minus negative 3 squared plus 5 minus negative 4 squared. So 5 minus negative 3 is 8, which is going to be a 64. Plus that's going to be 9, which is going to be an 81. And therefore, that's going to give me 100 and that's going to be 140, 145. Man, I didn't check this at all, did I? 145, so let's go and see. Now, when you're doing the 145, obviously you know it's divisible by 5. But you want to be able to see 145 divided by, I'm not sure if there's 145 divided by 5. That goes in there 29 times. So it looks like it's not going to be simplified any further. So there you go, ladies and gentlemen. That is going to be your distance. So that is how you find the distance between 2 points using the distance formula, which is, again, written right up there.